Alrighty, my name is Devon Pruitt, and for our last video in calculus, video number 4, we are to find the volume of a torus. T-O-R-U-S, or just a donut. Okay? So, let me show you what I mean by this torus idea. So this is the y-axis, and that is the x-axis. This is our cross-sectional area, which is just a circle of little radius r. This circle is shifted of r units. So its origin is r0, big R0, right? Alright, we're just gonna revolve around the around the y-axis, making our donut shape. I suck at drawing a donut, but that's alright. There we go. Alright, so let's look at the cross section of this on a two-dimensional plane. Boop. Little r. Alright, extend it out to r. Big R. Alright. So, the equation of this is r squared equals x minus big R squared plus y squared minus r, because our vertex is centered at r. Alright. So, to get this started off, we can take we can actually solve for x since we're doing it with respect to y, and we get x minus r equaling plus or minus the square root of r squared minus y squared. So we get two sets of x's equals x equaling r plus the square root of r squared minus y squared, or x equaling r minus the square root of r squared minus y squared. Okay? So we take the cross-sectional area of this circle, we get pi area with respect to y equaling pi times the radius big R plus r squared minus y squared squared minus r minus square root of r squared minus y squared squared, and the whole is in this quantity times pi. And again, this is just the area of the circle with respect to our big R and little r values in an x fashion. Alright, so if we expand this out, we get r squared plus 2 square root of r squared minus y squared plus r squared minus y squared minus r squared. Again, this is minus because this minus sign right here, plus 2 times the square root of r squared minus y squared. Ooh, never mind. It's going to be a minus sign because it's minus. See, it gets tripped up. Alright, so minus r squared plus y squared. This cancels. These cancel. Excuse me, no they don't, because again, I can't see. This was actually supposed to be a plus, so these don't actually cancel. It'll trip you up. R squared cancels, and your y squared cancels. So you're left with a sub y. Remember, this doesn't cancel, equaling this pi times 4 times 4 big R times r squared minus y squared. We flip to another page and we get that we take the integral of both sides with respect to y. We can find the volume of a torus, okay? Alright, so volume with respect to y. We're going to evaluate this looking at our cross section again based off of that. Alright, so we're going to evaluate this from negative r to r because, again, we're doing it with respect to y. This is our lower bound, negative r, and this is our upper bound, positive r. Right? Okay. So we can simplify this equation. V y equaling 4 pi r times the integral r squared minus y squared dy, negative r to r. We can actually do this from 0 to r, because if you recall, half of a circle is just 1/2 pi r squared. So really, we can just actually say this to be 2 times the integral of 0 to r of square root of r squared minus y squared dy. So we can simplify this again to say we have y equaling 8 pi r times the integral of square root of r squared minus y squared dy. Okay. Lastly, if you recall in my earlier videos, 1/4 the area of a circle with respect to y from 0 to r square equals the square. Sorry, 1/4 the area of a circle equals the integral of from 0 to r the r squared square root of r squared minus y squared with respect to y. So we can plug that into the equation here. 1/4 the area of a circle, which is just 1/4 pi r squared, and for this monstrosity right here. So we end up getting v sub y, we have y equaling 8/4 pi squared times r squared. And if you simplify this to a 2, you get v sub y equaling 2 times pi squared times big R times little r squared. And that is your answer. Thank you for watching.